right, here we go. Section 4.1, talking about segments and a little bit about midpoints, but that will come more next week. But 4.1 today. Our vocab word here. Our vocab word is postulate. That goes a little bit with our vocab word that we had before, which was theorem. Can anybody tell me the definition of a theorem? Yes. Yeah, somebody did a bunch of work and they proved it, and now it's always true because of that proof. A postulate is, oops. Oh, I got rid of it. A statement that is accepted as true without proof. Postulate. So it's a much more basic idea because there doesn't need to be a proof for it, but it is accepted as true and nobody had to prove it first. That's what postulate means. You'll see the word postulate in this box here. This box means it's an important main idea for today. It is segment addition postulate. It is very basic. I think some would say very easy. I would like you to draw a segment of any length and put a dot anywhere you want on that segment. Let's call it segment AC, and then you can put B anywhere you want. Hello. Yep, thank you. Segment addition postulate says this. Says AB plus BC equals, any guess? AC. That's the segment addition postulate. Very basic. So if I were to give you numbers like this is 3 and this is 10, what would AC be? 13. Yeah, very, very easy. You would not have to show work for something like that. What if I said AB is 5 and the whole thing is 20?
It's 15.
It's 15. So we don't always add the two numbers given. It depends what we're given. We will always add these segments together to get the whole thing. Will it always be that easy? No, because we wouldn't be doing it in high school. We would be doing it at a much younger age because it's so easy. You will get things where it's like, you don't need to write this down. This is x plus 5, and this is 2x minus 7, and this is 5x plus 15, something like that. You're going to follow the same basic idea. This is going to go here. This is going to go here. And this is going to go there. Same idea. It's just not mental math in our head. But we're going to add this segment to this segment to get the whole thing. We will have to draw pictures for almost every question. Number 1, use the segment addition postulate and draw a picture to complete each statement. Here we go. If B is between C and D, don't read the whole sentence. There's a lot going on. Just stop there and draw that. B is between C and D. It did not say middle. It's just anywhere in between. Once that's done, keep reading now. B to C is 10. You don't have to label it. That's okay. With inches. B to D is 3. So what is C to D? 13. No work is required for that. Number 2, if Q is between R and T, draw that. R to T is 24. Here's how I draw that usually. It's kind of hard to draw the whole thing, so I just kind of draw this big sort of extended bracket. R to T is 24, got that. This should say Q to R, I think it's O. Q to R is 6. We want to know Q to T. Can we do this mental math in our head?
Yes.
Yeah. What do you get? 18. Now, you can set your pencil down or you can write this. I'm going to show a lot of work here. The work is optional for a problem like this. But when we get to much more difficult questions like 3 and 7 and 8 and so on, you're not going to be able to do mental math. So you'll want to go through the steps I'm about to go through for all the harder questions. Here's how it looks in an easier question. I would use the segment addition postulate, which says RQ added to QT equals the whole thing RT. R to Q is listed as 6. Q to T is my only unknown. I can call it X. The whole thing RT is 24. I do regular algebra. I'm trying to get my variable by itself. So I subtract 6 on both sides. I get 18. This is the process we will go through for all of the harder questions that cannot be done with mental math. Any questions so far on segment addition postulate? This is segment addition postulate. What segments add together to get the whole thing? Number 3, if P is between L and A, go for it. Okay, once you've got that drawn, read the next part. P to L is X plus 4. P to A, 2X minus 1. And L to A, 5X minus 3. I can't do this in my head. I have no idea what X is. I probably could if I tried hard enough, but I'd probably make a mistake if I did it mentally without showing any work. We're going to go through that process. We're going to write this segment addition postulate with letters first. I'll get you started. LP. Tanner, then what?
Yeah.
P what?
Or PA.
Yep. L to P plus segment PA equals what, Taylor? Yep. And it's okay if you say AL. It doesn't matter. You know, it's a segment, so you say LA or AL. Either is the same thing. Now that you have it in letters, you know what piece goes where. So LP, plug in X plus 4. Plug in what you know for PA. This is algebra you should be familiar with. Some of us are faster than others. I'll walk through it. If you want to work ahead, you can. I'm going to combine like terms. I'm not moving anything across the equal sign yet. I have an X and a 2X on the same side. That's 3X. I have like terms of 4 and negative 1. No changes to the right side. Now I will be moving things across the equal sign. I'm going to get my X's together first. Then I'm going to move my 3 to be with my other 3. So I get x equals 3. Oftentimes there is a follow-up question. Here there is a question. What's LA? Well, that's no problem. Here's LA. So I'm going to take my x, plug it in. Oh, no calculator even needed. 5 times 3 is 15. Minus 3 is, I do not require work for that sort of follow-up question. A picture is required. Then you have 2 geometry steps. Then you have about 4 algebra steps. 4, 5, and 6. These are maybe a minor portion of the lesson, I would say, not a major part. It will appear on a quiz or test, but the other part that we just did, this and this, will be worth much more points. But you will see this, so let's talk about this. Number 4, what is KL? When they're asking it that way, they're asking for the distance. Like how far is it from K to L? There are 3 ways you can do this. The first way, you count, you manually count. Okay, that's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That could get difficult if you're not given a good number line. The numbers are super far apart, so I would not advise doing it that way. Here's the way that would go with the formula. Let's write this down. Subtract the 2 in either order. Subtract the 2 in either order. Then take the absolute value. So I'm going to show my work for this down here. I'm going to subtract the 2. K minus L. I hear a lot of chatter back there, like after every problem. K is -9. Subtract. L is 15. We could use a calculator. What's -9 minus 15?
-24.
-24. Do we remember what absolute value means? Close. We can't say opposite, and I'll tell you why in a minute. It's the distance to 0. So how far away is -24 from 0? 24. So I just subtracted the 2, and I took the absolute value. I will do it in the other order. You don't need to write this down. Let's say I did L minus K. That would be 15 minus my K is -9. 2 negatives make a positive. That's 24. How far is 24 from 0 on the number line? 24. That's why I say not opposite, because I would hate for you to say negative. So that is how you find the distance between points. That works great if they're really far apart and you can't do it manually by just counting. Here's one way I like to do it. I like to look at 0 and say, oh, I know how far it is to L. That's 15 away. How far is it from 0 to -9? 9 away. That's how I do it. I just add those distances together. You could do it either way. Number 5. What is the midpoint of KL? Let's go ahead and mark your paper with what we just found, that this distance is 24. If I want the middle point and they're 24 apart, how far away is the middle point? 12. So let's go 12 this way and 12 this way. What number would I land at? 3. Easier for me to think about that from the 15. 12 away from the 15 is 3. Now, sort of a tricky question here for 6. Point C lies between K and L. So here's point, oh, it didn't go together. Here's point C. It's somewhere between K and L. Where is it? We don't know. Put it up here. Here's what we do know. The distance between K and C is 1/3 of K to L. How far is it from K to L? 24. Can I divide 24 into 3 equal chunks?
Yes.
How big would each chunk be? Okay, so think about this as 8, 8, 8. Point C is 1/3. So of those 3 chunks, it's one of those thirds away. So what would 8 away from this number be? Yes. Again, that's kind of tricky. Kind of a couple steps to it. Not a major part, but you'll still see occasionally. Seven. We have a new word here. Q is the midpoint of PR. So you can no longer put Q wherever you want. You have to put it in the middle, the exact midpoint. Here's the way you show your reader it's the exact middle point. Kind of like when we do right angles, we don't just do that. We do this to say it's exactly 90. In the same way, we don't just like eyeball the middle and just assume our reader knows it's the middle. To tell the reader it's the exact middle, we do this. Give them the same marks, saying these guys are the exact same. Anytime you see midpoint, you want to do that. All right, let's continue labeling P to Q. Q to R. Determine the length of PQ. Maybe set your pencil down for a second. Here's a really good start when you have segments or an image that looks like this. A good start would be segment addition postulate. PQ plus QR equals PR. Then I would fill this in. 4x minus 5, 11 plus 2x. I don't know the whole thing. Would it be okay to call this whole thing x? No. X has already been used in this problem, so I can't use x anymore. I could call it y, but then I'm dealing with 2 different variables. So segment addition postulate is a good idea. Good thing to start with, but for us, that's not working for this problem. Anybody have any ideas based on the picture what we might be able to try?
Using the exact control, we could just put each of the equations on different sides of the equal sign.
Yeah, think of it this way. If I have this, if this is 10, isn't this also 10?
Yeah.
They're equal. So he's saying that this is equal in this picture to this. So that's all we have to do. 4x minus 5 equals 11 plus 2x. I'll let you do your algebra by yourself. You'll notice I kind of like bubbled in this. This is not my answer. If you stopped here, you'd get a lot of points, just not all of them. Because it doesn't say what is X, it says what's the length of PQ. So we'll just have to plug it in. 4 times 8 is 32. Thanks. Subtract 5. 27. This picture started to look the same, but it was a little bit different because we didn't have all 3 segments. Number 8. Go ahead and get your picture and then we'll talk about it. Maybe put a period after WZ. Why is the midpoint of WZ period? I know, it's getting a little crazy there. You wouldn't believe the number of people that do this. Oh, I see the word midpoint, which means 2 things are equal. So I'm going to set these equal. Do we all see a problem with this?
Yes.
Look at your picture. You've stated that this little guy is equal in length or distance to this whole thing. That doesn't make any sense. It's better than leaving it blank. It's a good try, but it won't get you any points because it's not true. So, what should I do then? I can't really add them up because I only have 2 of them. I can't call this X because X has already been used. I don't really want to call it Y because then I'm dealing with X's and Y's. Anybody have an idea?
They're equal length. Equal
Yeah, I actually do know this because these are the same. So that's X plus 3, that's X plus 3. Good. Do we know what to do from here? I'm going to write my segment addition postulate with letters first. WY. Added to segment YZ equals WZ. Go ahead and plug each part in and do the algebra. Is 10 my final answer?
No.
Sometimes it will be. This time, determine the length of WZ. Plug that back in. We can do that without a calculator also. 3 times 10 is 30. Minus 4. Pictures are required. The work is required. Just a quick note before I go on. If I didn't, in the beginning, if I didn't draw this, I might not have remembered that this is also x plus 3. So when you see the word midpoint, try really hard to remember to mark those alike because that might help you solve it. 9. M bisects RS. Bisect. Bi means 2, tri means 3. So bisect, write this down. This is a word you'll hear all semester. Bisect. Cuts into 2 equal parts. So let me reread it. M cuts into 2 equal parts RS. Take RS. And cut it 2 equal parts. Pretty much just like the word middle point. Bisect, yeah, it's just like it. Don't forget, if you've been told it's the middle or it's been bisected, mark those 2 pieces alike. I'm going to let you label it and try to finish this problem on your own. Can we set those parts equal? That would make sense to say this piece is the same size as this one. Yes, you are allowed to set those equal. It's okay to kind of circle X, just know that might not be your final answer. That's one of my answers. What is X? What is RM? RM is X plus 3, so 7. Is there one question left?
Yes.
Does it say midpoint or bisect? Okay. This one is on your own. Try not to look at the board, number 10, until you're done. Do you need that still, Seth?